In this video, we will retrieve the equation for calculating the shaft work corresponding to the work exchanged by an open system. Therefore, if we have an open system, the work exchanged by this system will be the so-called shaft work. So let's deduce the analytic expression for this work. Firstly, being an open system, we can apply the energy rate balance, which by mass flow rate takes this form. Q equals enthalpy variation plus kinetic energy variation plus potential energy variation plus the mentioned shaft work. Well, it's important to be into account at this point that we will obtain the mathematical expression considering an assumption that is very usual in this kind of system, and this assumption is that kinetic energy variation and potential energy variation are almost zero. So, accepting this first assumption, we can consider negligible those variations, and then the previous equation for energy rate balance takes the following form. In turn, enthalpy variation equals the difference of the addance of internal energy plus the product of the pressure and a specific volume between inlet and exit. Or what is the same, Q minus internal energy difference between inlet and exit equals P2 V2 minus P1 V1 plus work. Well, this was the first assumption. That kinetic energy variation and potential energy variation between inlet and exit are negligible. The second assumption is that the process where that work is exchanged in an open system is reversible. Since the process is reversible, these terms equals the integral of pressure multiplied by the differential of volume, that is P2 V2 minus P1 V1 plus work, where this product is the integral from 1 to 2 of the differential of PV. Thus, we obtain that the shaft work equals the integral of pressure multiplied by the differential of volume minus the integral of PV. And this equals minus integral of volume differential of P. So we have calculated the analytic expression for shaft work, that is the work exchanged in an open system. This expression is valid only if kinetic energy variation and potential energy variation between inlet and exit are negligible, which, as mentioned, is very usual in the majority of the open system that exchange shaft work. And this is a very important point, only if the process can be assumed as reversible.